As we go into our very last set of guided notes, our last page, I want to start off with the meaning of a key vocab term, the word theorem. You may have heard of the Pythagorean theorem, a squared plus b squared equals c squared. But there are many theorems in mathematics, the Pythagorean theorem being one of the important ones. And this theorem, the three theorems we're going to use here are important, but a theorem in general is a mathematical statement that has been proved. So what does it mean to prove something? Well, I'm going to give you an example of a couple of proofs that something is true. We're going to assume a few key things, though. So whenever you are proving something, you start with assumptions. You start with things that you already know to be true. And we're going to start with three assumptions. Our three assumptions are one, the core, three assumptions, sorry. When lines are parallel, when two lines are parallel and they are cut by a transversal, whenever that's the case, we have three important theorems. One is the corresponding angles theorem, CAT. Corresponding angles theorem, CAT. And it says that corresponding angles are congruent. So going back to what we did 2 pages ago, we looked at what corresponding angles are, look back at that for what it means. Those are congruent. We're going to assume that those are congruent. We actually did an outline of the proof in the previous video. We're also going to assume vertical angles are congruent. So for example, A and C, or B and D, or F and H, or E and G are all vertical angles and therefore congruent. And linear pairs are supplementary, or we're going to put that as LP, or the linear pair theorem, I suppose, is going to be our assumption here. When you make linear pairs, for example, A and D, or E and F, any two that are next to each other forming a straight line, two angles next to each other making a straight line, are supplementary. That's the third one. We're going to assume those three facts, and we're going to use those to prove our claims on these parts. So we can prove the following theorems. I'm going to walk you through the two theorems that I have right here, the alternate interior angles theorem and the same side interior angles theorem, how we prove them, and as a should-do exercise, or actually an aspire-to-do exercise, you're going to prove the alternate exterior angles theorem and the same side exterior angles theorem down here. So what is our claim here? Our claim, we start off with what are we trying to prove? We're trying to prove that angle A is congruent to angle G. A is congruent to G. We're trying to prove that this is congruent to this. What are we assuming? We're going to assume the vertical angles theorem and the corresponding angles theorem. These are our two assumptions from up here. And what's our logic? How do we know? So we are claiming something. We're making some assumptions about what must be true. Then our logic is, well, A has to be congruent to C by the vertical angles theorem, A and C. Those two are vertical angles, and since we're assuming vertical angles are always congruent, that means that A and C are congruent to each other. A is congruent to C. And then we know that if A is congruent to C, but C itself is also congruent to G. Angle C is congruent to angle G, because these two are corresponding angles. So therefore, if A is congruent to C and C is congruent to G, that means A has to be congruent to G. And that's our last part, our conclusion. And we call that the transitive property. Oh, that's really fancy. What it means is just if one thing is the same as another thing, which is the same as another thing, then all three are the same. So if angle A is the same as angle C, and angle C is the same as angle G, then that means that angle A is the same as angle G. And that's pretty intuitive. That's what we mean by the transitive property. Is that if three things are the same as each other, then the two on the end are the same as each other. All right, and in this version, I'm going to allow you to work with me and try to prove the alternate exterior angles theorem. Alternate exterior angles theorem. So you can try this by yourself, you can work on it with me, whatever you want to do. Call me over, see what the best course of action is for you. your proof is going to go here. You're going to have it structured basically like what's over here. You're going to start with a claim. You're going to take two alternate exterior angles. So for example, B and H, or maybe C and E. Take two alternate exterior angles, and then you're going to prove they're congruent to one another using the claim, assumptions, and logic, and ending up at a conclusion. All right, last but not least, we have the same side interior angles theorem. We claim that A plus F is 180 degrees. A plus F, that this angle and this angle add up to 180 degrees. How do we know? Well, it's going to boil down to this. We know the alternate interior angles theorem. So we know that A is congruent to, or F is congruent to D. We know F is congruent to D. We know that those two are the same. That's the alternate interior angles theorem right here. And we also know that if F is congruent to D, and A and D make 180, then that means A and F also have to make 180. And here's the logic written out here. We've got our assumptions. We assume alternate interior angles, and we assume that linear pairs sum up to 180 degrees. We're allowed to assume this part. You might be like, well, wait, how can we assume that? Well, we proved it up here. We proved that statement up here already, and since we proved it, we can now assume it to be true. Well, linear pairs sum up to 180 degrees. That's our third assumption at the top. So we've got these two. We proved this. This was already given. And then our logic is, well, A plus D is 180 because of 2. That's the linear pairs, because A and D form a linear pair. A and D make 180 degrees. Angle F and D are the same by the alternate interior angles theorem. So the two measures are the same as each other. So when you add them up, you'll get A and F are going to equal 180 degrees, because if A plus D is 180, then A plus F has to be the same thing, because F and D are the same thing. We just replaced D with F. That's substituting F for D. And therefore, A plus F has to be 180 degrees. And that proves what we wanted to prove, that these two add up to 180. To summarize the meaning of this all the way through is, if you have A and F, and you want to prove that they equal 180 degrees, well, just note that A and D make 180. These two together make 180 degrees. But D and F are the same thing. D and F are the same thing. You could also do it like this. You could say A and D, or A and B. A and B, those make 180 degrees. And B is the same as F. So if A plus B is 180, and B is the same thing as F, then A and F have to make 180. All right, and that's our proofs.